Ethyl ethanoate can be made by reacting ethanol with ethanoic acid in the presence of concentrated sulfuric acid. So here we've got ethanol, here we've got ethanoic acid, and at the other side we've got our ethyl ethanoate. A mixture of ethanol, ethanoic acid and concentrated sulfuric acid with anti-bumping granules is heated under reflux for 10 minutes. The apparatus is then rearranged for distillation. The mixture is heated to collect the liquid that distills between 70 and 85 degrees C. The distillate is placed in a separating funnel. Sodium carbonate is added and the stopper is placed in the funnel. The mixture is shaken, releasing the pressure as necessary. The lower aqueous layer is removed and the upper organic layer placed into a conical flask. Calcium chloride is added to the sample in the conical flask. The mixture is shaken well and left for a few minutes. The liquid from the flask is redistilled and the distillate is collected between 74 and 79 degrees C. So there's a lot of information here about the required practical that involves producing and purifying an organic liquid. The first question we're being asked is to state the role of the concentrated sulfuric acid. So it's needed, but it's not in the overall equation. We can tell that means it is a catalyst. It says the reaction mixture is flammable. How should we heat it in step 1? Any answer here that does not involve a naked flame, so no Bunsen burners, but an electric heater, a water bath, anything like a hot plate, anything like that would work. Figure 1 shows how the students set up the apparatus for reflux in step 1. Assume it's clamped correctly. Identify 2 mistakes the students set up in the apparatus. So they've got all of their mixture things in the flask and they're heating it, but what we can see is that they've put a stopper in the top here. That's going to allow pressure to build up because as the gases, as you're heating the liquids, they're going to turn into gases, vaporise, the gases are going to expand, there's going to be pressure build up inside there because there's nowhere for the pressure to go. The water is going the wrong way in our condenser. If it goes this way, it won't necessarily fill the condenser and we won't get efficient cooling. Water should be in at the bottom and out at the top. The diagram's not great and we can see that there are some very tiny gaps here. So with those tiny gaps, we could even say that there is the chance that the vapours would escape and not be condensed. But I'm going to stick to the 2 main errors that I circled to start off with. So mistake 1, there was a bung in the condenser. Pressure will build up in the condenser. Mistake 2, the water direction is incorrect. Water should be in at the bottom, out at the top. Problem caused. The condenser will not fill with water and may not cool efficiently. We may not get all of our condensing, our liquids condensing. State why sodium carbonate was added in step 4. So this was in the separating funnel, they added sodium carbonate. What we're doing with the sodium carbonate is we're trying to neutralise the concentrated sulfuric acid catalyst and any leftover carboxylic acid. So it's added to neutralise excess acid. Explain why there's a build-up of pressure. Well, CO2 gas is produced when sodium carbonate and acid react. Give a reason why 2 layers form in the separating funnel, and suggest why ethyl ethanoate forms the upper layer. So 2 layers form because ethyl ethanoate, being organic, is like an oil. It is immiscible, does not mix in water, or with water if you like. So the 2 products and the remaining aqueous reagents are not going to mix together. They're immiscible, so they're going to form 2 layers. Why is ethyl ethanoate the top layer? Well, that shows us that ethyl ethanoate is less dense than water. Why was calcium chloride, anhydrous calcium chloride, added in step 6? It is a drying agent. So we add a chloride or a sulfate, an anhydrous chloride sulfate. It's going to remove water. Any leftover water that we didn't tap out of the separating funnel when we were separating the layers. Any leftover water. 1.7. A student uses the method to prepare some ethyl ethanoate. The student adds 10 centimetres cubed of ethanol. So we've got 10, so a volume of 10 centimetres cubed of ethanol tells us its density is 0. I'll use the proper formula for density. Density is 0.79 grams per centimetre cubed. And its MR is 46. Then it says to 5.25 grams, and the MR is 60, of ethanoic acid, and obtains 5.47 grams of ethyl ethanoate with an MR of 88. Determine the limiting reagent and calculate the percentage yield of ethyl ethanoate. So let's work out the moles of ethanol. So we're going to have to turn the volume into a mass, so volume times density, and then we're going to divide that mass by the MR, and I'm going to do that all in one go. So the volume times the density is going to give me 7.9, so I'm going to do 7.9 divided by 46. I've got 0.172 moles of ethanol, and then my number of moles of ethanoic acid is 5.25 over 60. And do that on your calculator. 0.0875 moles. They're in a 1-to-1 ratio in the equation, so whichever one is biggest is in excess and whichever one is smallest is the limiting reagent. So ethanoic acid is our limiting reagent. That means to work out our percentage yield, the number of moles of ethyl ethanoate expected will be the same as the number of moles of limiting reagent used, so 0.0875. The number of moles of ethyl ethanoate actually formed equals mass over MR, 5.47 over 88, 0.0622. And so our percentage yield, 0.0622 divided by 0.0875 times 100. And we're getting 71.0% as our answer. Suggest a reason why the percentage yield is not 100%. So there's many reasons here. You could talk about side reactions, byproducts, incomplete distillation, loss during transfer. But you could also notice that this reaction was an equilibrium, and as a result, as it's reversible, we're never going to get 100% transfer over because there will always be some reagents, some of our reactant materials still present. But there are many other acceptable answers here because there are many other possible reasons for not getting 100% yield.